Recording? All right, so we need to wrap up our conversation about metabolism. So, as promised, the very last thing I really want to talk about is the shape and functionality of enzymes, which, remember, serve as the catalysts for our activation energy. So remember on Friday, that was me changing the screen. We just finished up reviewing this conversation about catabolic reactions. Okay? So we have this reaction where energy is released. Okay? Sometimes they need to be slowed down so we don't end up accumulating too much or waste of the product. To do that, right, we have this activation energy, this hump or speed bump, that we need to get over. Okay? To get over that speed bump, right, we use a catalyst, right, a helper. Okay, so we had this big example at the end of class of the divorce of Janarl, okay, into the singles of Janet and Carl using their very specialized divorce attorney, the catalyst. So the last thing then that I wanted to talk about is really focusing on that divorce attorney then, that catalyst, and how exactly do those look, okay? And how is it that they do their job? How do they work? Right. So let's talk about enzymes, aka a form of protein, our favorite biomolecule. Okay, so remember that they are very specific for the reactions that they're catalyzing. We talked about this in our example too. Okay, remember that when we hired a lawyer, okay, to break up Janarl, we specifically wanted a divorce attorney. Okay, we couldn't hire any lawyer, even though there is a wide variety of lawyers. We weren't going to get one that worked with corporations. Okay, or did accident lawsuits. We wanted one that specialized in family law. Right? Okay, so if I look down here, okay, this is what an enzyme looks like. Okay, so this whole big blue business is the enzyme. Okay, so remember, we want to think about this as being the helper. Okay, it's going to carry or persuade our starting molecule to get across this activation energy easier and faster. On the enzyme, then, we have what's called the active site. This is the site to which the starting molecule is actually going to bind or hook into, where it will be then carried. And so we see that this active site is a very specific shape. And so this is allowing for that specificity between the starting molecule and the enzyme, or specificity of that catalyst to that reaction. That's not how you spell that at all, is it? So we see in this image here that the pink thing, which looks very small in comparison, is called the substrate. There we go. A substrate in this case is another term for reactant, aka the starting molecule. This is the thing that we're going to carry, we're going to move around and help over the course of this reaction to start breaking down. So the substrate is going to go into and fit very neatly into that active site. Okay, so our substrate and our active site fit very tightly. A good pair of gloves or a pair of shoes. With me so far? This is the key of what an enzyme or a catalyst looks like. Right, and nearly all catalysts are enzymes. Any questions so far? Okay, so that leaves us our last question. How do enzymes do what they do? Okay. So it's really answered no by this lower bullet. Okay. Our enzymes slash catalysts, right? Remember their goal is to lower that activation energy. We're lowering that speed bump. And they can do so via a variety of options or any combination of them. And we talked about this a little bit, sort of generally in our example with Gennaro on Friday. Okay, so we can strain bonds. We can literally pull and tug. Okay, we can orient our starting molecule, bit like a Rubik's Cube. Okay. We can provide a favorable microenvironment. Microenvironment referring to the tiny space where the enzyme and starting molecule are now taking up, right? Instead of them being in like their own little bubble. So we might change the pH of that area, might change the temperature. Okay? Kind of like how the divorce attorney made a nice room for the couple to sit in, gave them water, kept everybody calm. Okay. I send up new bonds, okay, for our singles. I gave Janet her own Tinder profile. Okay. So by doing any of these things, okay, we're basically setting it up so it's more likely, faster, easier for the original large molecule to break up. That's our goal, right? We're going to break those bonds, get that energy out. And so we've seen what an enzyme slash catalyst looks like. Now we have a good idea of how they work. Okay, now we're going to walk through an example. But any questions before we do that? That's okay. So here I have a different view of what it looks like to have a catabolic reaction. Okay? But I still have a reaction with which we're going to break a bond, theoretically get energy out, right? We're just not graphing it in a way where we're watching the energy in any way, right? But here I have a large single macromolecule. I can see the bond between them. This might be like general. So that's my beginning. You can imagine this is our progress of reaction. And way over at the end down here, I have my two single molecules, right? Janet and Carl. Okay, with no bond between them, they're single. Okay. My big purple thing is my enzyme, okay, which in our example is like the divorce attorney. First of all, lawyer for a second. Okay, so we can see on our enzyme, okay, my two grooves, which is our active site. Remember, the active site is very specific, right? This is allowing for our specificity. So you can see that this is the perfect shape for the type of couple, the type of reaction, and the type of thing we want to do. It'll be a perfect fit. And so, as we go through the progress of the reaction, and we know that we would need to get over that activation energy. So to do so, Gennaro, okay, the couple, the bond, okay, is going to go in and bind to that enzyme. They're going to use the divorce attorney. Okay, perfect fit. And here, if we look at this particular spot on our figure, we can see some of the things the enzyme does. Remember, it can do many things. Okay, but in this particular case, we can see that bond straining, right? Janet, you do not want the boathouse. Enough. Okay. So as the reaction continues to proceed, and we see that that bond is broken, the divorce attorney does her job. Gennaro gets divorced, becomes Janet and Carl. Okay. They are released. Theoretically, we also get some energy out of the deal, right? That's the point of a catabolic reaction. And of course, another key, remember, our enzyme is unchanged. Our divorce attorney does not become part of the product. She gets to leave, go about her business, help other couples in need. Okay, so still same enzyme. Same old lawyer. Any questions about anything about enzymes or any of the stuff that we've covered in metabolism? All right. So what I would like you to do next is cover your notes up and take out a fresh sheet of whatever it is that you do, right? Whether that's a sheet of notebook paper or an MS Word document. Okay, and what we're going to do is an in-class activity. Boy, has it been eons since we've done one of those, right? What you're going to do is craft me two now it's in a bad mood. I don't know where it went that time. Why? Happier? Okay, craft me two drawings for real this time. All right, this first one. Okay, I want you to draw me an enzyme with a substrate, that starting molecule. Okay, and be sure to label me the activation site. Where is that? Okay. The second drawing. Must be too close to the edge. I want you to draw me a free energy diagram. And that's the one where we track the direction of the energy as it goes through the progress of the reaction. Okay, so make sure that you label your axes. And I want this particular energy diagram to be catabolic. Certainly, I think we can agree on partial. Okay. Once you draw a good line graph of a catabolic energetic equation, what I want you to do then is associate those four words with your line graph. Okay, just kind of like what we've been doing all along.